Hi everybody, welcome to a new Python tutorial. Today we're going to talk about lists in Python. A list is a collection data type that is contain an integer, a boolean, and a string. That's all possible. And the list allows duplicate elements, so if we put in another apple here, then we see that we have two apples now inside our list. Now if you want to access an element, you do that by referring to the index. So let's say item equals my list. Now if your item is. Now if we want to insert an item at a specific end, so some useful trick if you want to create a new list, then we colon 1 to index 5 and the last item. Hi everybody, welcome to a new Python tutorial. Today we're going to talk about the collections module in Python. The collections module implements special container data types and provides alternatives with some additional functionality compared to the general built-in containers like dictionaries, lists, or tuples. So we will be talking about 5 different types from the collections module. The counter, the named tuple, the ordered dict, the default dict, and the deck. So let's start with the counter, and first of all we have to import it from collections import counter. And the counter is a container that stores the elements as dictionary keys and their counts as dictionary values. So let's say we have a string called A with some different characters, A, B, 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 C, C, C. And then we can create our counter. We say my counter equals counter. And then we give it our string. And if we print it, then we see and their counts as dictionary values. So let's say we have a string called A with some different characters, A, B, 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 C, C, C. And then we can create our counter. We say my count equals counter, and then we give it our string. And if we print it, then we see we have a dictionary with all the different characters as keys and their count as values. So we have 5 times A, 4 times B, and 3 times C. And like with a normal dictionary, we can have a look at only the items. So this will give us all the key values. value pairs, we can have a look at the keys, and we can also, this will give us all the different values. And what's also very helpful is to have a look at them. So this will give us all the different values. And what's also very in our counter dictionary, so we say if we first print our counter again, and then we can say we want to print my counter dot most common. Very first, so the most common element with the count 5 is the two most common types, so it will also put the B in here, and this will return a list with tuples in it. So for example, if I want to have a look at only I want to see what is the most common element, then I will have to access the index 0. So this will give us the tuple at index 0. And then if I only want to see the element, then I will again have to access the first element of this tuple. So again 0. And then I will get or any other iterable, have a list. So if we, and this will give us an iterable, so I have to convert this to a list in order to print it nicely. So now if I print it, then I will see, I will get all the different elements here as a list, and I can, for example, iterate over this. So that's the counter. Next, talk about the named tuple. And of course, first of all, we have to import it. So we say from collections import named tuple. And the named tuples is an easy to create and lightweight object type, similar to a struct. So what I can do is I can define my named tuple. I say, for example, let's create a 2D point and call it point equals, and then I will say named tuple, and then as first argument I give it the class name. So typically this is the same name that I used here, and then as a second argument I use another string, and here I use all the different fields I want, separated by either a comma or a space. So I can say x, comma, y. So this will create a class called point with the fields x and y. So now I can create this point, so I can say pt equals point, and then I will give it values for x and y. So for example, I will give it 1 and -4. And now if I print my point, then I will see I have a point with x equals 1 and y equals -4. And I can also access the field, so I can say pt.x and pt.y. So then this will print the values for x and y. Next is the ordered dictionary. So from collections import ordered dict. And the ordered dict is just like a regular dictionary, but they remember the order that the items were inserted. So they have become less important now, since the built-in dictionary class has also the ability to remember the order, since Python 3.7, this is guaranteed. But for example, if you, so what I can do is and this will give us an iterable over elements, repeating each as many times as it counts. So I have to convert this to a list in order to print it nicely. So now if I print it, then I will get all the different, the named tuple. Tuples is an easy to create and lightweight object type, similar to a struct. So what I can do is I can define my named tuple. I say, for example, let's create a 2D point and call it point equals, and then I will say named tuple. And then as first argument, I give it the class name. So typically this is the same name that I used here. And then as a second argument, I use another string, and here I use all the different fields I want, separated by either a comma or a space. So I can say x, comma, y. So this will create a class called point with the fields x and y. So now I can create this point, so I can say pt equals point, and then I will give it values for x and y. So for example, I will give it 1 and -4. And now if I print my point, then I will see I have a point with x equals 1 and y equals -4. And I can also access the field, so I can say pt.x and pt.y. So then this will print the values for x and y. Next is the ordered dictionary. So from collections import ordered dict. And the ordered dict is just like a regular dictionary, but they remember the order that the items were inserted. So they have become less important now since the built-in the ordered dictionary. So from collections import ordered dict. And the ordered dict is just like a regular dictionary, but they remember the order that the items were inserted. So they have become less important now since the built-in dictionary class has also the ability to remember the order, since Python 3.7, this is guaranteed. But for example, if you use an older Python version, this may be a way to use a dictionary that remembers the order. So for example, let's create a dictionary like so, and then we can append key value pairs like with a normal dictionary. So we say here in brackets, give it a key A and a value 1, and let's do this with some more key values. So let's say we have B, C, and D, and 2, 3, 4. And now if you print this, then we see it's the same order as we inserted it. So for example, if we inserted the A at the very end, then it will also get printed at the end of our ordered dictionary. Yeah, since here I'm using Python 3.7, so in this I can also just simply use a normal dictionary now, and it still remembers the order. Next, we have a look at the default dict. So from collections import default dict. And the default dict is also similar to the usual dictionary container, with the only difference that it will have a default value, an integer here as default example C. Then what will happen, it will return it Q, and it can be used to add or remove elements from both ends, and both are implemented in a way that this will be very efficiently. And yeah, let's create a deck. So let's say D equals deck. And then we can append items like with a list. So let's say D append 1 and D append 2 and then print it. So now we see our deck here, and also we can say D dot append left. So this will add elements at the left side. So now we can see our 3 got added here. And we can also again remove elements from both sides. So we can say D dot pop. And now if we print our deck, then we will see that with pop, this will return and remove the last element. So now the 2 got. Note that we will see that this will rotate higher group by function and some infinite iterators. So let's start with the product. So first of all, we have to import it. So we say from itertools import product. And let's say we have 2 lists, A equals 1 and 2 and B equals a list with 3 and 4. And then we say we have a product of A and B, and the product will compute the Cartesian product of the input iterables. So let's print this. So print the product, and then we will see that we have a itertools object. So this is an iterator, and to see the elements we can convert it to a list, and then we will see the product. So the product will combine 1 and 3 and 1 and 4 and then 2 and 3 and 2 and 4. So this is the product. We can also define a number of repetitions. So if we say repeat equals 2, then it can repeat, and let's run this, and then we see that this is a very large list. So let's make our second iterable smaller and print this, and then maybe the repetition gets clearer. So we have 1 and 3, and since we can repeat again, we do 1 and 3, then we have 1 and 3 and 2 and 3, 2 and 3 and 1 and 3, and again with repetition 2 and 3 and 2 and 3. So that's the product. Then we also have something called permutations. So permutations will return all possible orderings of an input. So let's say we have one 1, 2, and 3 as a input, and then we calculate the permutations of A and print this again as list. And then we see all the different orderings. So we have 1, 2, 3, 1, 3, 2, 2, 1, 3, 2, 3, 1, 3, 1, 2, and 3, 2, 1. So that's permutations. And we can also specify the length of the permutations as a second argument. So if we want to have shorter permutations with only length 2, we give it the argument 2. And then we see different orderings with the length of 2. So 1, 2, 1, 3, 2, 1, and so on. That's permutations. Then we have combinations. So from Iteratools import combinations. And the combinations function will make all possible combinations with a specified length. So let's also make an example here. Let's make a list 1, 2, 3, and 4, and then say comp equals combinations of A, and the second argument with the length here is mandatory. So in this example I only want the length 2, and then print this again as a list. And then we will see all possible combinations with length 2. So 1, 2, 1, 3, 1, 4, 2, 3, 2, 4, and 3, 4. And note that we don't have combinations of the same arguments, so no repetitions here. And if we want that, we can also use the combinations with replacement function. So then we import it. So import combinations with replacement. And then let's make another combination iterable and say combinations with replacement of A and also of length 2, and print this. Comp with replacements, and then we see that it will make combination of 1 and itself. So 1 and 1, 1 and 2, 1 and 3, and so on. So this is combinations and combinations with replacement. Now then we have the accumulate function. So the accumulate function makes an iterator that returns accumulated sums or any other binary function that I will give as input. So let's make an example. First of all, import the accumulate function, and then we can say we leave the list A equals 1, 2, 3, and 4, and then we say accumulate equals accumulate of A, and print this. First of all, let's print our list and then print the accumulated list. So we see that our list is 1, 2, and 3, and the accumulated sums is 1, 3, 6, and 10. So the first element stays the same, and then we have 1 plus 2 is 3, 3 3 plus 3 is 6, and 6 plus 4 is 10. So that's the accumulate function, and by default it will compute the sums, but we can also, for example, multiply the elements. So let's import operator, and then we can give as second argument, we can say func equals operator dot mul. So this will multiply each element, so 1 stays the same, 1 times 2 is 2, 2 times 3 is 6, and 6 times 4 is 24. And as a third example, let's just use the max. So this will return the max for each comparison. So for example, if we have a 5 here in between and have a look at our list, then 1 is the same, 2, now 2 is the max, then compared with 5, and then 5 is still the max, compared with 3, then 5 still the maximum, and compared with 4, 5 is still the maximum. So that's accumulate. Now let's talk about the max. So this will multiply each element, so 1 stays the same, 1 times 2 is 2, 2 times 3 is 6, and 6 times 4 is 24. And as a third example, let's just use the max. So this will return the max for each comparison. So for example, if we have a 5 here in between and have a look at our list, then 1 is the same, 2, now 2 is the max, then compared with 5, and then 5 is still the max, compared with 3, then 5 still the maximum, and compared with 4, 5 is still the maximum. So that's accumulate. Now let's talk about the group by function. The group by function makes an iterator that returns keys and groups from an iterable. So let's make an example to make this clearer. Let's say we have our list A equals 1, 2, 3, and 4. And then we say we make a group object, and that is group by, and then we want to group A, and we have to give it a key which has to be applied. So as key we can define a function. So let's say smaller than 3 and give it an input, and then return x smaller than 3. So this will return true or false, and as a key we will give it this function. And so we have our input array A, return an output. So I can write the same function in one line with a lambda expression. So I can write lambda x and then colon and then simply x smaller 3. So this will do the same thing. If I run this, then it will print the same thing. Now let's make another second example for this. Maybe this is not clear at the first side. So let's define a object persons, and this is a list, and inside this list we have different dictionaries, and the dictionaries contains a name and an age. And let's say we want to group our persons by the same age. So and then we say lambda x and simply x, and as key the age. And then if we run this and print this, then we will see as keys we have the different values for age. So we have 25, 27 and 28. And then we also see that it grouped Tim and Dan together because they both are 25 years old. And that's the count function is very simple. So if we just say for I in count and then give it a start value, so let's start at 10 and then print this. So this will make an infinite loop that starts at 10 and then adds 1 for every repetition, so 10, 11, 12 and so on, and this is still going now. So then for example, if I say if I is 15, then we break, so then it will stop at 15. That's the count function. Then there's the cycle function, so this will cycle infinitely through an iterable. So let's say we have a list that has 1, 2 and 3 and we want to cycle through A, the repeat method, so then this will simply make an infinite loop and will print 1. And I can also as a second argument give it the stop repetition, so how many times do I want to repeat. For example, if I say 4 here, then it will repeat the 1 4 times. Yeah, that's all about data tools. I hope you enjoyed this tutorial and see you in the next tutorial where we'll talk about the Lambda functions in Python. Hi everybody, welcome to a new Python tutorial. Today we're going to talk about Lambda functions in Python. A Lambda function is a small one-line anonymous function that is defined without a name, and it looks like this. First it has the Lambda keyword, then it can take some arguments, then a colon, and then an expression. And what this will do, this will create a function with some arguments and it evaluates the expression and returns the result. So let's look at an example to make this clearer. Let's call a function and we call this add10, and this is equal a lambda with an input. And let's call our input x, and then it should evaluate x plus 10. So this will create a function with one argument, and it adds 10 to the argument and returns the result. And we assign this function to our variable add10. So now this is a function that we can call with an argument input. And let's call our input x, and then it should evaluate x plus 10. So this will create a function with one argument, and it adds 10 to the argument and returns the result. And we assign this function to our variable add10. So now this is a function that we can call with an argument. So let's call it with 5. And now if we print this, then it will print 15. So this is practically the same as a normal function like this. Let's call this add10 func, and this will take an argument x and return x plus 10. So these two things do the same thing, but the lambda function is much shorter and only in one line. So lambda functions can also have multiple arguments. So let's create another lambda function and call this mult, and this is equal lambda, and now we give it x and y, and it should evaluate x times y. So this will create a function with 2 arguments, and it will multiply these 2 arguments and returns the result. So Now if we print, for example, mult 2 and 7, then it will print 14. So that's the Lambda syntax. Lambda functions are typically used when you need a simple function that is used only once in your code, or it is used as an argument to higher order functions, meaning functions that take in other functions as arguments. For example, they are used along with the built-in functions sorted, map, filter, and reduce. And we will have a look at all of them to make the usage of Lambda clear. So let's start with the sorted method. So you probably already know this, and I also showed this in my video about lists. So let's say we have a list and we call our list points to D, and the list has tuples with 2 elements in it. So you can think of this as the x and the y values of our points. And now if we want to sort this, so let's create a points to D sorted list, and then we can call sorted. This is built in, so we don't need to import anything. And now if we want to sort this, so let's create a as arguments. For example, they are used along with the built-in functions sorted, map, filter, and reduce. And we will have a look at all a function as an argument, and then a sequence. So this is, for example, a list. So let's create a list points to D, and the list has tuples with 2 elements in it. So you can think of this as the x and the y values of our point, and 5, 10x, or define a function of our points. And now if we want to sort this, so let's create a points to D sorted list, and then we can call sorted. This is built in, so we don't need to import anything. And now we can sort our list. So we want to sort points 2D. And now first print our points, and then print our points 2D sorted. So by default, this will sort our list by the first argument, so by the x arguments. So 1, 5, 10, and 15. But we can also give it a specific rule how to sort it. So we can say we can give it a key argument, and the key equals, and this should be a function. And as we now know, we can write a function with a lambda in one line. So we can say lambda with an argument x. And now let's say we want to sort it by the y value, so by the second index. So then we say x of the index 1. So now if we run this, then we will see that our list got sorted according to the y index. So what this does is you can also, for example, give it or define a function, and let's say sort by y, and then give it a index, and in this give it an argument, and in this case the argument is a tuple, and then it returns the first index. So now we can also use this function here, so sort by y, and if we run this, then this will return the same result. But now we see with a lambda we don't need this, and then we can simply use our lambda here. So we can use our lambda here and get rid of this function, and yeah, that's one use case of a lambda. For example, let's make another example of sorting. Let's sort this according to the sum of each. So therefore we would say lambda x and then evaluate x of index 0 plus x of index 1. Now if we run this, then we see that it got sorted according to the sums of each tuple. So that's the sorted method with a lambda is a function as an argument, and then a sequence. So this is, for example, a list. So let's create a list with some numbers in it. So 1, 2, 3, and 4, and 5. And now let's create another list and call this b equals. And now we will want to multiply each element by 2. So let's say map, and then as a function we define a lambda with an argument and evaluate x times 2. And then as a second argument we use our list, and then we print this. And if we want to print this, then if we simply print it like this, then it will print a map object. So we have to convert it to a list first. And then we can see that each element got multiplied by 2. So that's the map function. However, you can achieve the same thing with list comprehension. So you probably already know the list comprehension syntax. It's a little bit easier, so you can write it like this: C equals and then let's say x times 2 for x in A. Now if we print this, then this will do the same thing. So personally I would prefer this syntax. It's a little bit easier, but you should have heard about the map function. Now the second function is the filter function. So the filter function also gets a function and a sequence, and this function must return true or false, and the filter function will return all elements for which the function evaluates to true. So let's also give it a 6, and let's say we want to filter this, and we say b equals filter, and let's say in this example we only want to have the even numbers. So then we create a lambda with x and we evaluate x modulo 2 equals 0. And then if we run this, we should get only the even numbers. So again, here we can achieve the same thing with list comprehension. So we can also write C equals a list, and then inside our list we write x for x in A, and then we can give it a condition. We can say if x modulo 2 equals 0. So if we print C, then we see that this will do the same thing. And as a last function, I want to show you the reduce function. So the reduce function also takes a function and a sequence, and it repeatedly applies the function to the elements and returns a single value. So let's say I have a list here, and I want to compute the product of all the elements. So let's call this product A equals, and then I can say reduce, and in Python 3 I have to import this now. So I have to say from functools import reduce, and then I can call the reduce function, and as a first argument I give it a function. So I define the function here again in one line with a lambda. I say lambda x, and now it has two arguments here. So the function for the reduce function always has two functions, has two arguments. So let's say x and y, and then it should evaluate x times y, and as a sequence I give it a. So let's print the product. So this will print, let's make this, for example, smaller. Then we can see it has 1 times 2 equals 2, 2 times 3 equals 6, and 6 times 4 equals 24. So yeah, that's the reduce function, and that's all I wanted to show you about lambdas. I hope you enjoyed this tutorial, and see you in the next tutorial where we talk about exceptions in Python. Hi everybody, welcome to a new this one. So if I say import another one b equals error, so if I want to access an index of a dictionary, I want to print this. This will raise a syntax error because I have no any parentheses in. It will raise a name error. Such file or directory. Then there's the value error, which happens if the function or operation receives an argument that has the right type but an inappropriate value. For example, let's say I have a list with some numbers here. Hi. So let's print the product. So this will print, let's make this, for example, smaller. Then we can see it has 1 times 2 equals 2, 2 times 3 equals 6, and 6 times 4 equals 24. So yeah, that's the reduce function, and that's all I wanted to show you about Lambda. Higher, and then as a string variable a equals 5, and another one b equals c, and c is not defined yet, so if I run this, then it will raise a name error. Name c is not defined. Then there's the file not found error. So let's say I here 1, 2, 3, and now I can remove elements from a list with the dot remove method. So I say a dot remove 1. So this works fine. So now I print a, then the 1 got removed. And if I try to remove the 4, which is not in the list, then this will raise a value error. So list remove x not in list. Then there's the index error. So if I want to access an index of a sequence or of this list that is too large. So for example, if I try to access the index 4, then this will raise an index error, list index out of range. So let's say we have a variable x equals, and as message we give it x should be positive. So now if we run this, then this will raise this exception, x should be positive. And now if we give it a value of larger than 0, then error. We can also give it a message here. So x is not positive. And now statement, so you can say version that x should be larger or equal to 0. And now if we run this, then this will raise an assertion error. We can also give it a message here. So x is not positive. And now this will print the message here. And if our statement is correct, so x is positive, then your code will be just fine. So if I run this, then no assertion is here. Now, if you want to handle exceptions, so you can catch exceptions with a try except block. So you write, for example, you write try and then colon, and then you can do some operations. So let's say run this division error. If we run this, a cleaning up. So for example, class, for example, we can use a dot message equals message. Hi everybody, welcome to a new Python tutorial. Today we're going to talk about logging in Python. Python already comes with a powerful built-in logging module, so you can quickly add logging to your application by simply saying import logging, and then you can use this levels of the date format. And so in this case I set level to logging.debug, and then for the format I give a string, and inside the string I can specify this log record attributes. So for example, I can have the name being logged, and I do this by saying or by writing percent and then in parentheses name and then s, or I can say the ASC time, so this logs the time, then the level name and the actual message, and then I can specify how the time should be logged by saying date format equals and then give a string for the date format. And for this I can also have a look inside the documentation. So here, then it's best practice to not use this root logger, but to create your own logger in your modules. So let's say we have a helper module here, and what you do then after importing logging, you log something. So for example, say get logger function and then dot create our string, and this only has the error message. Formatter and give it conversion table. And by the way, you can find this on my website python-engineer.com. There you can find written tutorials to all my other video tutorials. You here we see that JSON data looks very similar to a dictionary. So it consists of several key value pairs, and as values it can take strings or numbers or booleans, or also nested types, like here a nested array or a nested dictionary. And we can also have a look at the whole conversion table. And by the way, you can find this on my website, python-engineer.com. There you can find written tutorials to all my other video tutorials. And this is how Python is translated to JSON and vice versa. So a dictionary in Python is an object in JSON, list and tuple. Let's start working with it. So let's say we have a Python dictionary and want to convert it to a JSON format, and this is also called serialization or encoding. So let's say, let me copy this here. Let's say we have a dictionary called person, and this has a name, an age, a city, a boolean if it has children, and then titles, and this is a nested list. And let's say I want to convert this to a JSON object. So first of all, I have to run this, then we can see the different separators here. Hi everybody, welcome to your use to generate pseudo-random numbers for various distributions. And it's called pseudo-random because the numbers seem random in the range from 0 to 1. Rand int, and it will pick a random int statistics. So this will pick a random value. Have a look at the red line. So let's say a equals random dot choice, where elements can be a random choice. So let's cells 3 shuffle use found. So this will produce a random integer in the range from 0 to 10, and 10 is not included. Then you have the secrets.randBits method equals 15. So this will generate, usually you will do it like this, and then you can say, for example, you want a array with random float by 4 random of the seed method from the random module that we've seen previously. So these are two completely different seed generators. And yeah, that's all about working with random numbers. Hi everybody. The function passed as an argument to another function and even returned from other function. So now let's have a closer look at the concept. So let's say we have a function and call it print name. Creating this inner wrapper function, I also have to return it. And now to apply this, let's first of all let's execute the print name function. So now if I run this, it prints Alex. And in order to apply the decorator, I assign this print name function to our decorator function, and as argument I take the print name function. So now the print name function has this new functionality. So now if I run this, we will see that it prints start, then executes the function and prints Alex, and then it prints end. And now the decorator function will do the same thing as this line. So now if I write at start and decorator, then I don't need this anymore. So this now does the same thing. If I execute it now, it will also print start, Alex, and end. And now this is how we can extend the behavior of a function with a decorator. So let's see what happens if our function has some arguments. So let's say we have a function, call it add5, and this takes an argument, and then it returns x plus 5. And now if I try to run this, add 5, and this argument I give 10. Now if I run this, I will get a type error because our wrapper takes 0 positional arguments, but 1 was given. So here I need the same arguments as here, and to fix this I can use the args and quarks. I will talk about this in another I used function. So now if I run this, I see that it now knows the help on function add5, and also our function name . Hi everybody, welcome to a new Python tutorial. Today we're going to talk about generators in Python. Generators are functions that return an object that can be iterated over, and the special thing is that they generate the items inside the object lazily, which means they generate the items only one at a time and only when you ask for it. And because of this, they are much more memory efficient than other sequence objects when you have to deal with large data sets. They are a powerful advanced Python technique, so let's have a look at some examples to understand how they work. A generator is defined like a normal function, but with a yield keyword instead of the return keyword. So let's define a function, call it my . generator, and here I can return, or I
Python programming. Now, advanced Python programming goes beyond with general intermediate Python, or the Python tips and tricks tutorial series that I have means double unders for double underscores. And then again, later on, I didn't want to use something very specific that I'm using in my daily coding life, so to say. But now I think in the advanced series, you choose your own editor. I choose my editor. I think Vim, NeoVim is probably the best editor for me. So I'm coding with this one. And I think it has also a little bit of an advanced touch to use Vim in a tutorial. But again, you can choose whatever editor you like. This is not going to limit you in any way. However, double underscore methods have a certain special type of being executed. So for example, if I create a new person object, and we all know this because if you're watching the series, you should of course be familiar with basic object-oriented programming. We can say p equals person, and then we can pass a name like Mike and 25 years old. This is how you actually call the init method. You're not saying person.init. You're not saying p equals person.__ init. This is not how you do it. You say person, so you just specify the class name and you call the class name, so to say. And this is what triggers the init method. So it's not just called like a regular method. And we have a bunch of different methods that work like that. Now init is the constructor. We also have the destructor by saying del. I think del was a keyword, right? So we say del, and here we can say, I don't know, print object is, there you go. And you can see object is being declared. However, whenever the object gets deleted or destructed, we're going to get this this thing here. So we can actually go ahead and say python3 main.py. I think I need to save it first, sorry. There you go. And you can see object is being deconstructed. So we construct it, and then we trigger this del function here. And of course, we already know, I think, from either the Python tips and tricks tutorial series or from the intermediate series that we have in Python something called operator overloading. So we can say define, and then we can define what happens when we add two objects. Now, for persons, this may not make a lot of sense, so we're going to do a different class. We're going to say the class is called vector, and a vector essentially has also the init, and then we have self, and then we have x and y, for example, a two-dimensional vector. And what we do is we say self.x equals x, and self.y equals y, and then we say actually nothing more. Now, the question is, we now have this vector class, and we probably know how to deal with vectors, but our Python script doesn't really know what a vector is, and it doesn't know what x and y actually means. Now, for us, this is obvious. We just need to say x plus x and y plus y, but the vector class has not defined the operation. So we can actually go ahead and do something like print, or actually let's create them first. Vector1 equals vector 1020, vector 2 equals vector 5060, for example, and then we want to say vector 3 equals vector this, you're going to see that we're going to get a type error, unsupported operand types for plus, vector, and vector. This does not work. So what we need to do is we need to actually use a dunder, a magic method, and we need to say at self and other. So we need to pass the other object here, and then we can say, okay, the result here, we need to return it. The result is actually just a new vector, and this vector is going to have self.x plus other.x. Now this, of course, in this case, of course, other also has to be a vector, which of course we're not checking because Python is dynamically typed, so we can also pass anything else. But if that anything else doesn't have the field x, we're going to get an error, because you can see we get 60 and 80. There you go. So now you can maybe want to do, and of course, before we get into that, we can also do sub, and we can do multi. We want to do, and of course, because we're adding 10 and 50. And the next thing that we now maybe want to do, and of course, before we get into that, we can also do, but what we can also do is we can also think about representing the vector, because right now, if I go ahead and say, okay, I'm not going to print the individual fields, but I'm going to print the whole vector here, what I'm going to get here when I do this is I'm going to get just the vector object. I'm going to get just a message telling me, okay, this is an object of the class vector, but it doesn't really tell me anything about the values. And in order to change that, I can change one of two methods here. I can either change the string method here, which essentially says what happens when I typecast the vector into a string, or I can change the representation method here, which essentially tells me, or we tell it how. If you represent and like that and do this, we're going to, so we could do it like that. And if I now go ahead and do this, we're going to see that we get the proper representation here. Go ahead and the purpose of you that this is how object you would say object to string. For example, in Java, you would do it in a different way. In Java, you would have something like def to string, and then you would have, in this case, of course, in Python, the self object, and then you would return a string. And whenever you try to get the information about that vector object, you would say object.toString. This is the Java magic method of doing things, and in Python, you do it object.toString. And whenever you try to get the information about that vector object, you would say object.toString. This is the Java way of doing things, and in Python, you do it with the representation dunder or magic method. It's very important to know that on anything to documentation, but I'm going to show you two more, and the first one is the length, so len, and it essentially just triggers whenever you apply the length function onto an object. I'm just plus y a collection, it's not the amount of elements. Of course, I'm going to get manipulating, that's kind of interesting. All in Python, you can call objects like functions. So you can say, for example, let's just print a message here. Hello, I was called v3, for example. And you're going to see that this produces the result. Video of the advanced Python tutorial series. Let me know in the comment section down below. Then we have the decorated output. Result is the wrapper function, that actual wrapper function. So if I run this right now, we say hello to a specific person and return it by just calling it. I need to get the return value from the wrapper as well. And when I'm not doing it like that, if I'm directly returning, or if I'm practical example, your practical example 2 is going to be timing function. So for this, we're going to import time, and we're going to have a decorator called time timed like that. We're going to pass a function here. We're going to do anything, but before we do anything, we're going to call the actual function call of the passed function is happening in this particular that. Oh yeah, I need to return the wrapper. I'm not sure if that's the problem though. Yeah, seems to be the problem. And then what I'm doing here is I'm just saying, oh, and we need the value as well. Actually, we don't need the value. We can just call the function here. So I guess I can get rid of that. Yeah, like that. So we can just call the function here in this case, unless we're returning something. Actually, maybe we should return it though. Yeah, let's do a return here. So let's say value equals that, and then after the print, we're just going to return the value like that. And then we're going to add the tag here, but first of all, again, let's just see what happens if we just say print my function 10,000, let's go for 100,000. Let's see if this kind of works. Here we get 0. Why do we get 0? We have, oh, because we start at 0. That's not good. Let's do it like that. And it takes some time, maybe takes too much time. So let's go with 1 less 0 here. And you can get a result here. So if I now go ahead and time this, we're going to get a timing as well. So we're going to get timed here. And I think the message somewhere up there. Maybe we should not print it. Maybe we should just execute it without the print. So let's get rid of that and get rid of that, so that we only see the execution time. You can see it took 0.025 seconds. Now if I change this to a 9 here, maybe it's going to take longer. So hopefully not too long. Yeah, there you go. 5.6 seconds to execute. So this is one other practical example. You could just go ahead and have this time decorator whenever you want to know how fast the function executes, and maybe some other values as well. So I'm going to show you how we can work with generators and what we can use them for. So let's say we just want to have a program in which we have a sequence from 1 to, let's say, 9 million. Like that, and what we want to do with that sequence is we just want to, I don't know, take the number, each of those numbers to the power of 3, so cubing it, and then we want to print the result. Now, one primitive way, of course no one's going to do it like that, but one primitive way to do it is to just say 1, 2, 3, 4, 5, and so on until you get to 9 million and so on. And then you could just What is going on, guys? Welcome back to the Python tutorial series for advanced programmers. In today's video we're going to talk about generators, so let us get right into it. Alright, so let us talk about generators, and I'm not going to give you a formal definition here of what a generator is. I'm going to show you how we can work with generators and what we can use them for. So let's say we just want to have a program in which we have a sequence from 1 to, let's say, 9 million, like that. And what we want to do with that sequence is we just want to, I don't know, take the number, each of those numbers to the power of 3, so cubing it, and then we want to print the result. Now, one primitive way, of course, no one's going to do it like that, but one primitive way to do it is to just say 1, 2, 3, 4, 5, and so on until you get to 9 million and so on. And then you could just iterate through the list and print x to the power of 3 every time. What we would usually do in this particular case is we would say something like for x in range 1 to 9 million. So we have 1, 2, 3, 1, 2, 3, like that. And then we would just say print x to the power of 3. Now the range function, however, is sometimes limited because we're essentially having a start and end, and then we have a step size, but we cannot create all kinds of different sequences. So what do we do when we don't have the range function, or we cannot use the range? Just say print x to the power of 3. Now the range function, however, is sometimes limited because we're essentially having a start and end, and then we have a step size, but we cannot create all kinds of different sequences. So what do we do when we don't have the range function, or we cannot use the range function for what we're trying to do? We have to build our own generators. Now generators have something that's called lazy execution. If you've ever programmed in Haskell, for example, you will know what that is. Haskell has lists, and you can say, for example, in Haskell you have a list that is 2, and then 90. And what you get then is you get the numbers from 2 to 90, but we don't get them as a collection, but we get them whenever we need it. So this is a structure that produces whatever we need when we need it. And this is something that we also have in generators in Python. So what could a generator look like? We could say def my generator, and we have to pass a number here. I mean, we don't have to pass a number, but we're going to pass a number for now. And in that generator, we can return something, but we're not going to return it in the way that we usually return it. We're going to use a new keyword here, and this keyword is going to be called yield. Now, yield is interesting because every time we get to that yield, we get the next element. So you can think about it like that. Let's say we have for, actually maybe we should not call this x, but call this n. And then we could say for x in range n. And then what we do is we don't get just, we don't return the value because we can only return once. We yield the value. So every time we get to that yield statement, we get the next iteration. So we can say yield x in this case, or x to the power of 3. And what we can now do with that is we can say values that we're interested in, is my generator up until 9 million, for example. So 1, 2, 3, 1, 2, 3. And now what we have is we don't have a list of all the values cubed, but we have a generator that is going to give us the next value cubed whenever we need it. So on demand, so to say. And we can see that this is the case by just saying print next values. So next is the keyword that we need to or next is the function that we call to get the next element from the values, and let's just enter that a couple of times. And then I'm going to open a terminal, split down here, bash py directory 9, there you go, Python 3 actually main.py. And you can see that we get all the cube numbers here. So we start with 0, 1, then 2 to the power of 3 is 8, 4 to the power of 3 to the power of 3 is 27, and so on. So you can essentially see that the next keyword always gives us the next yield statement. So yield is essentially just a way of returning a value, but not in the way that you then get out of the function, but you just get the next value, so to say. And you can not only do it with the next function here, you can also do it with iterations. So we can say, for example, for x in values, we can say print x. Now this is going to be a pretty, maybe we should decrease the number here. Let's go with 100 for now. And then we can go ahead and run the same thing. And you can see that we get all the different numbers here. But at the same time, no matter how much or what number we pass here, the size of my generator is not going to change. So we can, I think the library now, I hope I don't do any mistakes here, but I think the library is called, or the function is called sys.getSize. So let's say import sys dot, or actually just import sys, and then we should be able to do sys.getSize of, yes, there you go, get size of values in this case. And let's just get rid of all that. Run the same thing, and you can see that we get all the different numbers here. But at the same time, no matter how much or what number we pass here, the size of my generator is not going to change. So we can I create a new I think the library now, I hope I don't do any mistakes here, but I think the library is called, or the function is called sys.getSize. So let's say import sys dot, or actually just import sys, and then we should be able to do sys.getSize of, yes, there you go, get size of values in this case. And let's just get rid of all that. And then, yeah, 112 bytes, so to say, I think it's bytes. However, you can see that whatever I do here doesn't really matter, because if I add a bunch of zeros here, this is not going to change down here. So this is not going to change the size of this object, because the object is still 112 bytes large, because we don't add any data. We just say, okay, you go longer, but we don't add anything there. So one more thing we can do with generators that we cannot do with ordinary collections is we can create infinite sequences. So we can say, for example, def, oh, I have caps lock, def infinite sequence. And of course, we don't pass a parameter here because we don't have a limit. And then we can say, I don't know, the first one is going to be 1, and then I'm going to print all the powers of 5, for example. So I'm going to say while true, and I'm going to say yield the result, the current result, and then take the result times equals 5. So we will get 1 and 5 and 25, 125, so essentially 5 to the power of 0, 5 to the power of 1, 5 to the power of 2, and so on. this is a sequence, but it doesn't have a limit. Now, of course, if I go in a loop and say for x in this infinite sequence, we're going to go on forever, but I can go ahead and say, I don't know, values equals infinite sequence, and then I can just say print next of that sequence. I can do this a bunch of times here, and you're going to see 5 and 25, 125, so essentially 5 to the power of 0, 5 to the power of 1, 5 to the power of 2, and so on. This is a sequence, but it doesn't have a limit. Now, of course, if I go in a loop and say for x in this infinite sequence, we're going to go on forever, but I can go ahead and say, I don't know, values equals infinite sequence, and then I can just say print next of that sequence. I can do this a bunch of times here, and you're going to see that. What are we going to see? Like that. There you go, 1, 5, 25, 125, 625, and so on. And as I said, we can go on forever. We can also go in a loop here and say, okay, up until the 100th power of 5. But the point is, we have this infinite sequence. It doesn't store any values. It just yields the next value. It doesn't have any big collection of all the powers of 5, so we don't waste memory. But we still have a sequence that we can go on forever and get the next power of 5, unless we're limited by memory, obviously. Now, let me show you what happens if we just go ahead and say for x in values print x. I hope my system doesn't crash here. But essentially what happens here is we get, I mean, maybe it doesn't flush the output, so, oh man, it's crashed. It crashed. I said it's going to crash. However, you can see that it's crashing maybe if you're not running this on, oh, there you go. It loaded. So I think if you're not running this on a Windows Linux subsystem as I'm doing, maybe you're going to see them in real time here. But as you can see, it goes on forever and the while true loop gets executed, because actually this while true loop is only stopped because we have this yield keyword, because it says, okay, stop until we get the next value or the next value is requested. But when we're constantly requesting the next value, obviously we're going to go endlessly into infinity. So one way to counteract this is, of course, to just say for x in range, I don't know, I want to have 500 values, and then I can say next or print next from the values, or I can also in how many values. Other than that, thank you very much for watching. See you in the next video, and bye.
I can yield some values, so here I use the yield statement and yield a value, so I want to yield 1. And then I can have multiple yield statements inside a generator function. So I can, for example, also yield 2 and 1. And this will execute the function and runs until it reaches the first yield statement. And here it returns the value and pauses at this line. So the next time, if I want to get the next value again with this next function, so again, I say value equals next g, then it will continue here and runs until the next yield statement. So it runs until here and returns 2 and pauses here. So if I run this now, it will print 1 and 2. And if I do it again, then it will also return and print. I can, for example, use, I say cd print next. So print the value, and then it prints 4. And again, the next time I want to continue here with this next statement, let's say print next cd, then it will continue here. It will remember the current state, so the current number is 4. Then it will update the number. Now the number is 3. Then it will continue in the while loop, and then it stops again at this line and now returns 3. So now if I run this, this will also print 3. And then again it remembers the state, and the next time I continue, it will continue from here, and so on. And again, if I run this a couple of times, so again, if I print next, then it will also print 2, and now it will also print 1, and now it will raise the stop iteration. So this is the execution in detail. And now let's have a look at the big advantage of generators. So as I said, generators are very memory efficient. So what this means is, let's have a look at an example. Let's say I want a function, call it first n, and it takes a number as input, and this will return a sequence with all the numbers starting from 0 all the way up to n. So usually what you would do is you create a list, call it nums equals an empty list. And then you also say num equals 0, so this is your start number. And then you say while num is smaller than n, nums dot append num. So you add the current number to your list, then you update the current number, so you say num plus equals 1, and at the end you will return this list, so you return nums. And now I can say, for example, and here
able to parse arguments as long, of course, as you want it to have arguments. But let's look at an example here. Let's say we have this Python script called myscript.py, and this Python script has a certain functionality. Now, some scripts are not going to need parameters because just they work on their own. They're interactive. They're just launching something, so they don't need any parameters, any optional arguments. We just have the script itself, and we can call it using Python 3 myscript.py, and it's done. But sometimes you want to have parameters. So let's say myscript.py, what it does is it takes the text hello world and it writes it into a file that we have to specify here. So we call myscript.py, and after that we want to specify a file name. So a concrete command would be in Linux Python 3 myscript.py, and then I don't know, result.txt. Want to have it like that. So this is not something that we input in the Python script or into the Python script at runtime with the input method or input function, but we're actually passing the parameters, the arguments in the console, in the terminal. And maybe we can also have something like, before we do that, we can say -o is the output file, so we can say test.txt. Then we can say, okay, I want to have a certain logger, I don't know, or logging level has to be debug, and then I want to have, I don't know, just a tag for case sensitive, so -c, just some random parameters because executed on the command line. Sensitive, hey, I can pass a bool. Hey, true, 19, wow, test 7. Now, of course, if I skip on one of those, so for example, if I don't do this, and I say they work on their own, they're interactive, they're just launching something, so they don't need any parameters, any optional arguments. We just have the script itself and we can call it function, but we're actually passing the parameters, the arguments in the console, in the terminal, of parameters, of named parameters, and just positional parameters. So wow, and of course I will of course get an error message because 7 or something like that. Since we're passed, however, we're just going to pass 4 here, and then we're going to say print quarks, and quarks is a dictionary, so here we have to specify names. Let's just call it key 1 and maybe key 0, and then all. Obviously in Python this is quite simple, just use the length function here, and you don't need to have a special argument counter or something like that. You just say length, and then you can go through all the individual arguments. All right, now for the optional arguments, for the opt args, we need to have flag here's self and one. All right, so let's talk about encapsulation and data hiding. The basic idea is we have a class. Let's say we have a class person, for example, and this person has a constructor. So an init method here is self, and want to pass name, age, gender, or something like that. And what we do here is we say self dot private attribute, so 2 underscores for a private attribute, name equals name, and then we can copy this and we can change those values here to age, private age, and private gender. By the way, the names don't have to be the same, but I think you know that already. This is and this person has a constructor, so an init method here is self, and want to pass name, age, gender, or something like that. And what we do here is we say self dot private attribute, so 2 underscores for a private attribute, name equals name, and then we can copy this and we can change those values here to age, private age, and private gender. By the way, the names don't have to be the same, but I think you know that already. This is an advanced Python tutorial series. This one is actually right, so here we're going to say age, and here we're going to say gender. There you go. So this is a basic constructor, and now all those attributes are private, which means that if I say p1 equals person and I fill up those parameters here, and after that I want to say p1 underscore underscore name equals something, this doesn't work. This is not going to work in Python because those attributes, because of the 2 underscores, are set to private. So what we can do here using annotations is we can transform, or actually not transform, we can create properties that allow us to access those values, to read those values, to write into those values, through a property, through so-called getters and setters. And how do we do that? Essentially, we do something like a function. So we say def name, for example, with a capital N. This is the usual convention. And we pass a self attribute here. And what we do here is we basically just say return self dot underscore underscore name. We can access underscore underscore name because we're in the class, so it's private. We can access it. Now, this in and of itself, of course, would already work. But in order to make this a property in Python, we need to add the annotation called add property, like that. This turns this into a property that we can use later on. We're going to see what this actually means. And now what we can do in addition to that, if we want to have a setter, we have to say def name again and self value. So this is basically the setting function. And here we just say self dot underscore underscore name equals value, like that. And of course, in order to make this an actual setter, we need to say at name.setter. Now, this is interesting because in Python, we don't have method overloading. So we cannot specify usually. We cannot specify a method called name with self and then another method called name with self and value. This does not work. This works in C++, in Java, in other languages, but it does not work in Python usually. And as you saw, if I remove this here, we're going to get, hopefully, if it actualizes here, yeah. If it refreshes, I mean, method already defined in line 10. So we cannot actually go ahead and just define the same method with a different signature, but we can do it if we have this annotation of name setter here. So this is a very basic thing. We can go ahead and create this person element here. So we can say P1 equals person. This person is going to be Mike. This person is going to be 20 years old. And we're just going to pass a character M here, or a string M for male. And then we can say P1, or actually print P1 dot name, like that. Now we should open up a terminal in split mode. Oh yeah, I need to specify the argument. Bash, there you go. So we're going to navigate to the directory that we're currently at. And in here, we're just going to say python3 main.py. And you can see we get Mike as a result. Now, if we don't have those things here, let me just make this a little bit smaller here. If we don't have all of those things here, this is not going to work. We cannot just say print P1 underscore underscore name because it's private. At the same time, we don't want to have it public because what can we do in a setter? We can control stuff. We don't have a direct access to the variable. If I say something like self.name equals name without making it private, everyone that creates an object can just go ahead and manipulate the variable without any control mechanism. So I cannot check for variable. If we do in a this is not going to work. We cannot just want to have it print P1 underscore underscore name because it's private. At the same time, we don't want to have it public because what can we do in a setter? We can control stuff. We don't have a direct access to the variable. If I say something like self.name equals name without making it private, everyone that creates an object can just go ahead and manipulate the variable without any control mechanism. So I cannot check for certain constraints. Whereas if I use the setter, I always have to use, we haven't used the setter yet, but if I use the setter, we always have to go through this. So for example, I could do stuff like if value, actually we don't need those brackets here. If value is larger than 0, then we can set it, otherwise do something else and so on. Now we have a very simple setter here, but we can make it more complex if we want to. So we don't have, even though this is a public setter, we don't have direct access to the variable. Now in this case, we do have sort of direct access because we're not doing anything else but just assigning the value, but we can do whatever we want in that, and it's like the age can only increase, we cannot decrease. Just for demonstrational purposes here, we can say if the value for some reason if the name is Bob, we're not going to allow that. So we're going to, I'm not even sure how we do that. Either we return something, or we can just make a simple thing. We're just going to say self.__name is a default name, because we don't want to set Bob. If someone puts in the value Bob, we're going to say this is a default name, and otherwise we're going to set this value to whatever the value was, like that. So in this case, we're trying to set it to Bob, and it should get the value default name. We're going to see if you go through the setter, you have to, and we'll end up over our class. So I want to talk about two more annotations here, and the first one we're going to talk about is called static method. And as the name already suggests, we use it to define static methods. Now, I don't think that it's mandatory. I think you can define static methods without putting @static method above it, but it's best practice, and I think it will have some functionality. I'm not sure. But of course, you should be doing it if you're programming in an object-oriented context, at least for the hinting that this is a static method. And we can talk about two more annotations here, and the first one we're going to talk about is called static method. And as the name already suggests, we use it to define static methods. Now, I don't think that it's mandatory. I think you can define static methods without putting @static method above it, but it's best practice, and I think it will have some functionality. I'm not sure. But of course, you should be doing it if you're programming in an object-oriented context, at least for the hinting that this is a static method. And we can say something like def my method, for example, and obviously we're not going to pass a self keyword here, because remember, a class is just a blueprint for an object, and the object is then the concrete actual object, which has the values name, gender, age, and so on, with concrete values, and it also has all of the functionality. And whenever we want to have a function do something and work with the properties, work with the attributes, we need to refer to the object itself, so that an object has to know itself and has to be able to access its own attributes. And because of that, we need the self keyword. And since a static method is not related to a specific object, it's a method that works without any objects in the class directly, we don't need to pass a self keyword here. So we can actually pass nothing if we want to, and then we can just say something like print hello world here, just a basic hello world program. And now we can go ahead, and instead of saying something like p1 new person and so on, we can say person directly from the class my methods. So we don't need an object here to call this function. We can immediately call this function from the class. So that's it for today's video. Hope you enjoyed. I hope you'll hello world here dot my method. We can call it and we get the same result. Like if the type of, so if I have a function def my function, and I have a parameter here, my parameter, and I want to do something with that parameter, I have no clue what parameter this is. I have no clue, is this an integer? Is this a string? Is this a class, an object, a function? We can pass anything in Python. And this is a problem sometimes for predictability. Now, of course, what I can do is I can check during runtime. So I can do something like if the type of my parameter is equal to integer, for example, or type integer, I can do something with it. If it's a string, I can do something else with it. If it's a Boolean, I can do nothing with it, so I raise an exception or something like that. Or I can say if the type is not integer, then don't execute that function. But this is all happening during runtime. And since Python is dynamically typed by nature, we cannot really like if and I want to do something with that parameter, I have no clue what parameter this is. I have no clue, is this an integer, is this a string, is this a class, an object, a function? We can pass anything in Python. And this is a problem sometimes for predictability. Now, of course, what I can do is I can check during runtime. So I can do something like if the type of my parameter is equal to integer, for example, or type integer, I can do something with it. If it's a string, I can do something else with it. If it's a boolean, I can do nothing with it, so I raise an exception or something like that. Or I can say if the type is not integer, then don't execute that function. But this is all happening during runtime. And since Python is dynamically typed by nature, we cannot really change that. We cannot really have this handling before we actually get into runtime, because there's no compile time, first of all, but we can also for predictability. Now, of course, what I can do is I can check during runtime. So I can do something like if the type of my parameter is equal to integer, for example, or type integer, I can do something with it. If it's a string, I can do something else with it. If it's a boolean, I can do nothing with it, so I raise an exception or something like that. Or I can say if the type is not integer, then don't execute that function. But this is all happening during runtime. And since Python is dynamically typed by nature, we cannot really change that. We cannot really have this handling before we actually get into runtime, because there's no compile time, first of all, but we can also not have the interpreters say, okay, this is actually not okay because this should be an integer. This is just not a possibility in the basic vanilla Python. However, we have a tool called MyPy like that, which can check for so-called type hinting. So let's say I want to have this my function here, and the only thing I want to accept as a parameter is an integer. What I can do here is I can specify a colon and then int. This notation here means that I have the function my function, which has a parameter my parameter, and this my parameter we expect it to be an integer. Now, you can see that this doesn't mean a lot, because if I say something like, I don't know, print whatever we get as a parameter here, I can still go ahead and call this function, my function, on hello world, which is a string and not an integer. So I can go down here and I can, sorry, this is not what I want to show you here. Python 3 main.py, and you can see I get hello world because, you know, Python is still dynamically typed. I can hint whatever I want. It's like a comment. You know, I can say, okay, I'm expecting an integer here, but it's just a comment, so we don't really care. We can still pass a string because Python is dynamically typed. However, we have the tool MyPy, and I'm not sure if we have to install it. Chances are that it's not part of the core Python, so then you would have to do something like pip3 install or pip install MyPy. But once you have MyPy, either you have installed it or it's part of the core Python stuff, you can just go ahead and say MyPy and main.py. And then you are going to see main.py line 5 error argument 1 to my function has incompatible type string, even though we expected an integer. This is an error. Now, even though the code is not wrong in any way, MyPy says this is not consistent with the type hinting. So if I change this to 10, for example, this is going to work because then we're passing, in fact, an integer, and we're expecting an integer, so we get success, no issues found. Now, we cannot do this only for the parameters. We can also do this for the return value. So I can go ahead, add an arrow here and say, okay, the result I'm expecting here is a string. You know, you can just say it's a string. And then what we can do is we can actually go ahead and return a formatted string with, I don't know, my parameter plus 10 or something. And then we get the string as a return. So then I can go ahead and say print, and we should get no problem. So we can go ahead Python rename py, and you can see we get 20 as a result here. So now let's say we have a second function, another function, and we have another, or let's just call it other parameter, and here we're expecting a string. And now let's say we're not just expecting a string, but we're actually printing out that string. So let's say we want to print that string, other parameter here, and that's basically it. And then what we're going to do is we're going to pass to this function. We're going to pass the result of the first function. So instead of printing it, we're going to use this as one abstraction layer above the printing function, and we're going to say other function is going to be my function on the value 20, for example, and then we're going to print this. This should work because we're returning a string here, and then we can go ahead and say mypy main.py, and we get success, no errors, so we can execute it and you get 30. Now the interesting part here is that if this function says it returns a string and this function accepts a string, this is fine. But if this function returns an integer, for example, so let's say we